So, test preparations. Our target 1, trigonometry. Under trigonometry, what is important now here is you need to know the angles. Only special angles. So that you can use them to solve equations. And you know this. Because it will help you to prove identities. And then said you need to the font. It was not for me. Okay. Then you need to know the graphs for sine and cos. An idea of tan graph, what you least expect. So this is all we need on trigonometry. 2 logs and exponentials. Here you need 1, the properties of O. 2, an idea of the graphs of this and how to move from one to the other. And most importantly are the equations of the same. Then 3, calculus, meaning differentiation. The first one, calculus under differentiation. What do you need? You need to know the methods, that is first principle, power rule. This one is the most important because it holds product rule, it holds quotient rule, chain rule, and then implicit. Then you look at the second part of it. Or anyway, before you cross the other section, you can look at what you're calling further differentiation, where you look at checking for the gradients, meaning finding tangent and norm equations. Then you find what else, where the function is increasing and decreasing. Also knowing to be able to get the maximum and the minimum. Then you do the last part will be integration. We just look at the methods. That is 1, extended power rule. So here we also need to talk about limits. So extended power rule. Then you also look at substitution. Then you look at by parts. Then you are done because now you're looking at partial. Partial fraction. Then a bit of some applications. This is what you need to know this night. And of course you will know it. The night is still young. And you use these same things to revise for the exam on these topics. So now you can go. Trigonometric. What must we know first? How many trig functions do we have? We have 6 of them. 1, sine. 2, cos. 3, tan. But tan can also be written in terms of sine and cos. Then 4, you can also write it, we also have cot x, which is cos over sine. And then 5, sec x, which is 1 over cos. Cosec x, which is 1 over sine. Then from these 6, we now need to move to the quadrants. This is where we find angles. Now we are saying from 0 to 90, 180, 270, 360. I can also write 0 in degrees, in radians as 0, 90, pi over 2, 180, pi, and this guy 3 pi over 2, and then 2 pi. Meaning I'm converting pi is equal to 180. That's the conversion I use. Excuse. Then the next thing now is in the first quadrant, which is this section here. Then this one we call it the second quadrant, the third, and the fourth. In the first quadrant, all the 6 here, they are positive. In the second, out of the 6, only sine and cosec are positives. And you can see the reason why cosec is positive is because it is made of sine. In the third quadrant, only tan and cot are positives. You can see they are all made of sine over cos, cos over sine, so the same thing happens for both. In the fourth quadrant, only cos and sec are positive, meaning that the other angles not mentioned in here are negatives. Now, how can they ask me a question on the quadrants? There are so many ways, and the first way is they can ask you to say the quadrant in which maybe they can say state a quadrant in which sec is less than 0, sec theta is less than 0, and cosec theta is also less than 0. Which quadrant is that? Of course, to be the third quadrant, because it can be here, sec is positive, it can be here, cosec is positive. So it has to be here, because if it goes in the first one, they are all positive. Alternatively, they'll ask you questions like, if sec theta is 5/3. And cosec theta is negative, meaning less than 0. Find the other trig functions, or they can specify. Find tan theta. They're asking you first for the quadrant. Which quadrant here? Sec is positive, 5/3 is positive, cosec is negative. So of course, cos is only positive in the first, sec is only positive in the first and the fourth. But out of those two, where is cosec negative? That is the fourth quadrant. So you say, oh, okay, so I'm doing the fourth quadrant. So I'll go there and put a triangle. The triangle must always touch the x-axis. So it will touch the x-axis, that is theta. And it's 5/3. So now that is sec. But I know that sec is the same as what? 1/cos. So now we're using theta. So 1/cos. Now this is equal to 5/3. You cross multiply, you get 3 is equal to 5 cos theta, divide by 5, divide by 5. So cos theta is 3/5. So you pick 3 that side, the adjacent, that is cos from SOHCAHTOA. We have from SOHCAHTOA. That is cos is adjacent of hypotenuse. So we have 3, hypotenuse is always positive. So now I look for the other side using a right angle triangle. So you say 5 squared minus 3 squared, that is 25 minus 9, which is 16. Then get the square root. That will be 4, and it must be negative because you are in the negative side of the y-axis. Then now find tan. What is tan theta? Opposite of adjacent. And opposite here is -4. Adjacent is 3. If they asked me for cot, cot is what? 1/tan. So it is 1/-4/3, which is -3/4. If they asked me for sine, sine is what? Opposite of hypotenuse. So it would have been -4/5. And you are seeing why we say they are all positive here, only these are positive because of how the triangles sit in each quadrant. Do we have any question here?
So, can you repeat again? How is it connected? Because here on the first one, the connection between cos theta is less than 0 and cosec theta is less than 0. In connection to this question for sec x 5/3.
There's
How
no
are you
connection.
doing it? What was your final answer on this one for cosec?
So here the question was, suppose they ask you to know which quadrant this, we use in that instruction. Which quadrant do you find that? So we are saying in the quadrant where both of them are negative, that would be the third quadrant. Then the question ended here.
All right. So then the next one, how did?
Then this is the next question now. That was 1. Now we're on 2.
Okay. Then after substituting substituting the 1/cos theta here, you swapped the 5/3 here. You wrote it as 3/5. Why did you?
Because you have 1/cos is 5/3. Solve for cos.
Oh, okay.
So the next part now will be the special angles. So here you can use any method that you know that gives you the special angles. Okay. The first one is where I use the table method to get the special angles. And the table, we say we have sine here, we have cos here, and then we have theta. So theta is 0.
Sir, sorry for disturbing, but I just want to see something on the previous page. So this question for the first one, cos theta, just leave it as 3/5. Don't you simplify it further?
Which one?
The first one here, cos theta 3/5. You just leave it as like this.
The question was find tan theta.
Oh, okay. All right.
And you cannot simplify it further.
All right, thank you.
So I have 0.
Gonna kujoina. Kwanza hapa
So 0, 30, 45, 45, 60, 90, 180, 270, 360. And then for the first 5, you count 0, 1, 2, 3, 4 for sine. For cos, you count 4, 3, 2, 1, 0. And then divide everything by 4. You do the same here. And then get the square roots. So you notice that when you simplify, I now transform the table, I bring it here. I have 0, 30, 45, 60, 90. So I'm bringing the simplified ones now. This will be 0, this will be 1/2. This will be root 2/2. This will be root 3/2. That will be 1. That will be 1. Root 3/2. Root 2/2. 1/2, 0. When you extend to 180, 270, 360. For sine, you say 0, -1, 0. For cos, -1, 0, 1. So like that. Now, if I have these two, from this relationship here, one is able to get all the other ones because they just follow that pattern. Okay. Okay, so meaning that you can find all the other angles using just these two. So you can find tan, you can find cot, you can find what. That is if you want them. Okay. Then now that is the other method is where I use triangles. So when you have two triangles, we have this one that has 60, 60, 60. And then you break the 60 into 2 so that it gives you you break it. So what was 60 now becomes 30. In this one 90. This one 90. Also on the right to be the same thing, but this is 60. That is 30. This is 60. And now the sides, they were 2, 2, 2. But the one that is down, we have broken it into two halves. So this will be 1. That will be 1. Now you're looking for the middle one. So what we are saying is we have extracted a triangle here. This is 60. That is 30. And this is 2. And this is 1. So what will be the other side? It's going to be 2 squared minus 1 squared, which is 4 minus 1, which is 3. So it will be root 3, because this is 90. Then from there now, you know, you use SOHCAHTOA. So you say sine theta. So when you say sine 30, it must be opposed over hypotenuse. So the opposed is down here, 1 over hypotenuse 2. If I say cos 30, adjacent, which is root 3, over hypotenuse 2. If I say sine 60, opposed, root 3, hypotenuse 2. If I say cos 60, the same thing, opposite, so adjacent 1, hypotenuse 2. Okay, if I say sine 90, sine 90 becomes opposite of the angle, 2 over hypotenuse 2, so it is 1. Then what's the other one? So if you want to say cos 90 adjacent, but there's no adjacent here. So the adjacent is actually 0. So you have 0 over hypotenuse, which is 0, like that. Okay. So this is for 30 and 60. You can also form the one for 45. Say, what about for 45? This one comes direct. Okay, 90. And then hypotenuse, that is 2. Then what else? So if network logs you out, just try to connect back, because if you call, I won't be able to pick up. Okay, now we're looking for 45. So I put 45 there. I put 45 there. Then how do I get the angles? So sine 45, that must be so these are the same always. Sine 45 and cos 45. So you're saying, so that is 2, then this is root 2, then this is also root 2. So that when you square these and you add them, you get 4, then you square it, you get 2. So sine 45, it will be opposite hypotenuse, so you say root 2 over 2, and also there root 2 over 2. Alternatively, you can draw this angle in another way, where you say, I'll say 2, 1, 1, and then I put 45, 90. So you say, except when you do so, that must be root 2. So that you say sine 45 is going to be 1 over root 2, and cos 45 is going to be 1 over root 2. So to keep going like that. So meaning that I have all the angles. And these are what you call the special angles. If you know this, then you're done. Because you can solve any equation. The only thing that you need to take note now is when you're asked to find, you see these quadrants. In the first quadrant, we call this angle that sit here as reference angles. So each reference angle has got a corresponding angle in the other section. If you do that, you find its corresponding angle in the second quadrant. Here, in the third quadrant, you find the corresponding theta to x. Here, you find the corresponding theta to x in that quadrant. And so, if they ask me that, if I'm solving something, they find that sine theta is half. My question is, where is sine positive? In the first quadrant and the second quadrant. Which angle gives me positive in the first quadrant? For 30, which angle gives me half? Then you check here. 30 gives you half for sine. So I'm dealing with sine 30 is half. So theta is 30 in the first quadrant. Where else do I find theta to be? Where else is sine positive? Second quadrant. What is the corresponding angle to 30 in the second quadrant? So I'll go there and say my theta is 180 minus 30, which is equal to 150. So to be 150. Okay. If sine theta was negative half, I got the first quadrant. I first forget about the negative. I concentrate on the half. After concentrating on the half, I get that my theta is 30. But sine is not, but there's no 30 in the third quadrant where sine is negative. And also in the fourth quadrant. Now, how do I get the angle that gives me negative in that quadrant? This angle I have here, which I call the reference angle. If I go in the third quadrant, it is this angle on the left. So I'll say 30 is equal to x. In this case, I'm calling it theta because I'm looking for theta, minus 180. So theta is going to be 30 plus 180. I take this the other side. So I'll get 210 degrees. There's also an angle corresponding to 30 in the fourth quadrant, which gives us half, but it is just negative because of the quadrant it has found itself. Now, how do I get that angle? In this case, I'm looking for what I have in my hands is this theta, the 30. I'm looking for x. When I solve for x, it will still be x 360 minus theta. So I just do everything there. I'll say theta again is 360 minus 30. So I'll get 330 degrees. That's how I find the corresponding angles. Like that. So your first target is you ignore the sign. So you forget about the negative. You look for sine theta is equal to half. Which angle gives you half? You find for sine it is 30. Now this 30 is a reference angle. You're going to find the corresponding angles to 30 in quadrants where sine is negative. So you carry that angle and it's on the left of these that I've written here, the equations in each quadrant. So you are following in each quadrant which angle corresponds to your reference, which is 30. So you are making x the subject of the formula if you're coming with an angle from the first quadrant. And that's how we get the corresponding angles. So in the next video, we're going to do samples of equations, and then we solve for the theta. Then we move to the graphs, because now we only have 4 minutes before we are logged out. So I'm not allowing questions. Let's log out quickly and log back. So to look at examples and then move on to graphs. So let's do that just now.